My mic was muted. Welcome everybody to the Trolling with Logic 11th hour in our Atheist Helping the Homeless drive. We have Mortimer and we have Dr. Lawrence Krauss, our very special guest for tonight. Very happy to have you here, Dr. Krauss.
Yes, very.
Here.
I suppose we should just get straight on into it. I know a lot of people have a particular topic that they'd like us to talk about, but I'd like to save that towards nearer the end. So we'll start off. To refresh myself on you, I went ahead and I watched one of your lectures on A Universe from Nothing, where you were introduced by Dawkins. And I know this is probably something that you get talked to a lot about, but how did you come up with the idea of investigating this claim? Like, did somebody make the argument, well, you believe a universe came from nothing, and you went, that's actually a pretty interesting idea, or what happened?
Well, no, it's not that at all. What I've always wanted to do, of course, is not so much. Richard and I have discussed this many times. Is not so much destroy religion directly, as explain to people how the universe really works, and this is an area I've worked in for a lot of years, and there have been remarkable revolutions that have changed our picture of the universe, so remarkable that I think they should be more widely shared. And in the process of having lectured and written a great deal about it, I do get confronted often by people say, "Oh yeah, but you can't get something from nothing." And it is that. As I began to think about the issue more carefully, and as we've changed our definition of nothing tremendously, I realized that there was a lot to tell people, and in particular that if you put everything together, the story was eminently plausible that everything came from nothing without any supernatural shenanigans. So it seemed. I lectured about it, and of course, YouTube became kind of a YouTube hit. More people talking about it, and I thought a lot more about it. And I thought, well, a book where I could elaborate on those ideas and also answer some of the questions that people have had after seeing do things a little more carefully would be worth doing, and I guess it turned out to be the case.
Certainly, you get confronted a lot. I know. I've seen blog posts, I've seen news article posts where a lot of people are just like, "Well, you're not talking about nothing in the way that we are," and yeah. You're like, you're not. It's very frustrating for them, and one of the responses I always see from you is like, well, I don't really give a shit what you call nothing. You know what I mean?
Well, I don't quite say it that way. I just realized the coffee maker's on. It's going to burn. I'll be right back. Hold on.
All right, see you in a sec.
I'm back. I just want to turn this off before the house burns down. I think a lot of people would like. Well, when they find out that you can create, something from nothing, and depending on what the version of nothing is, their attitude is usually disappointment because they don't want that to be the case. And as I said, some people define nothing to be that from which only God can create something. So whenever you explain that their present version of nothing doesn't require that, they say, well, then that can't be nothing. It's got to be something else. And the bottom line is that words like theory are misunderstood in the public's mind, and science changes the meanings of words as we learn. That's what progress is, and the whole definitions of something and nothing and what they mean, first of all, are scientific concepts, and that's where I've come into a lot of problems with some theologians and a number of philosophers. Somehow that scientists shouldn't be allowed to redefine words, but nothing is not a philosophical concept. It's a scientific one, in the sense that if something is physical, then nothing is physical, and the only way to learn about it is to ask the universe. And therefore, people don't think my ontological. If they somehow find that what we're talking about is not what they'd like nothing to be, then I say, who cares?
It just blows my mind. I mean, as a philosophy student, it's just something that really confuses me when you say, if something and nothing will be made out of the same thing. Like, they're diametrically opposed things to me, and
Physics allows nothing to turn into something, and they're not so different anymore. Nothing is much more complicated when you think about the universe. And the fact that it logically seems crazy is one of the things to say, who the hell cares whether your logic seems crazy to you? Because the universe doesn't care about your logic. The universe, in fact, behaves in many ways that defy classical logic. That's the whole point of quantum mechanics. Electrons are spinning in many different directions at the same time, and in many different places at the same time. You measure them and you find it here, but before you measured it, it was everywhere. And that's crazy, but it's true. So get over it.
and that is one of the crazy things about it. That's just one of the crazy things about quantum mechanics, is that logic really holds no purview over that.
Well, I mean, once you understand it, you have to redefine your logic, and I think that's the point. An open mind requires you to force your beliefs to conform to the evidence of reality instead of the other way around. And so if something seems crazy to you, then the onus is on you, if it's true, and the universe behaves that way, the onus is on you to try and understand how to redefine your logic so you can understand how such a thing can happen.
Marty, did you want to say something?
Yeah, what is nothing?
Well, in some sense, it's the absence of something, and then you can ask for something. But in my book, I'm pretty careful, in spite of what some people say, because they don't. A lot of people like to write about my book without reading it, which is always unique, including reviewers for the New York Times. But anyway, there's a variety of ways of thinking about nothing. You have to be very careful. So the simplest version of nothing, the nothing of the Bible, if you wish, is an eternal dark empty void, an eternal space, devoid of any substance, but out there, an eternal dark empty nothing. Well, that, of course, empty space, turns out in modern physics to be quite an interesting quantity, and in fact, the simple answer is that kind of space is unstable. Quantum mechanics tells us there's virtual particles popping in and out of existence, and moreover, if you wait long enough, empty space will produce.
Yeah.
Oh, jeez.
I'm a physics teacher, okay? So I know some of this stuff. Lund is about to explode, but but I'm pretty familiar with some of it. But one thing that confuses me about the idea of a universe from nothing is, does nothing have dimension?
What do you mean by dimension?
Yeah, I mean, does it occupy space? Does it?
You didn't let me finish my thought, so let me take you a little bit further. What I talk to you about is eternal space, empty space. That'll always create something. So the simplest answer to something rather nothing is unstable. But that kind of nothing may not be satisfying you because it involves space. And you might say, well, if there's space, that's not nothing. Now, of course, as I told you, before I explained to you what I just did, you might have said, oh, well, an eternal dark empty space is nothing. If there's no particles, it's nothing. But now you say, well, I don't like that too much, so there's space. Well, then I tell you, you apply the laws of quantum mechanics to gravity. If you try and do that, we don't have a full quantum theory of gravity. But what that would do is turn space into a quantum variable. And that means spaces could pop into existence. That means there's no space, no time, nothing. And that's possible given what we think quantum gravity should allow. And therefore, you don't start with any dimensions, no nothing. You just create a closed three-dimensional universe. And in most cases, that three-dimensional universe will go away again like that. But under certain conditions, it'll survive long enough for people to talk on Skype about it.
Oh, jeez. I just one of the. It is. I'm not against any of it. It's just how much it blows my mind.
Let me finish the sentence. So of course it blows your mind. That's what science is for. But it's to make you uncomfortable. It's to make you think, and to realize the universe is a lot more grand than you might have imagined. But the point is, the only kind of universe that could last long enough to have a Skype conversation happens to be the kind of, if you ask what would be the properties of a universe that was created from nothing that would last long enough for us to evolve in it. And you know what? Those properties happen to be pretty well identical to the properties of the universe we see. Now, does that prove that our universe came from nothing in that sense? No, but it's highly suggestive, and it's at least plausible, and that alone is worth celebrating.
Yeah.
It's certainly all scientific discovery and all plausible hypotheses and theories are certainly worth taking into account and understanding the implications of them, and it's just the way you word things. I just don't understand it, and I know it's because I'm not a physicist and I just don't understand physics all that well, and I know that's the reason. When you say like nothing is a quantity, for me, I don't get it.
Well, look, if something is physical, then is not the absence of something physical? Also, by the way, I should ask you, I'm getting these text messages from people with questions. I don't know whether I'm supposed to answer them or not.
Yeah,
anyway.
I guess it's appropriate
Well,
that we ask them.
Yeah,
these are actually questions that I had in mind anyway.
What's your problem? The point is, if something is a physical quantity, then the absence of something is physical quantity.
Yeah.
It's just like saying 1 is a number, but somehow not liking 0 being a number. If you're going to define, your definition of nothing depends crucially on your definition of something.
Yeah.
Right? And so, and you can't have a valid definition of something unless you study the universe and know what something is.
We have a question from DPR Jones. Why is there more matter than antimatter?
That's a really good question. We don't know the answer. It's any sensible universe should have an equal amount of matter and antimatter. If you created it and you were a divine creator, you decided to create it, you'd create an equal amount of matter and antimatter, because matter and antimatter are more or less the same thing. We've learned that every particle in nature has what's called an antiparticle associated with it, which has the same mass but opposite electric charge. And if you have a certain amount of energy and you want to divide it up into stuff, it'd be natural you'd produce the same amount of matter as antimatter. But that would make for a very boring universe, because all the matter and antimatter would annihilate, producing nothing but pure radiation. And we now understand that you could do this in principle by quite a subtle mechanism. In fact, I wrote about it in a book once, that all you need in the early universe is some mechanism to make one extra particle of matter for every billion particles of matter and antimatter. And then the billion particles of matter and antimatter will annihilate, and that'll produce the cosmic microwave background radiation we see today, where there are 10 billion photons, particles of light, for every proton in the universe that we see today. And so you just have to have a mechanism that's very subtle, so subtle you wouldn't have even noticed it in the early universe, that somehow creates a slight asymmetry between matter and antimatter. And then all the antimatter will annihilate with the matter, and there'll be some matter left over that can't annihilate with anything, and that'll produce all the galaxies and everything we see. It's an amazing idea, and we even think we sort of maybe understand how it works, but we don't know for sure. It's one of the things we may hope to learn about the Large Hadron Collider. But we think you could just have to create a very small asymmetry between matter and antimatter in the early universe, and boom. But antimatter sounds like it's exotic, but it's not. I like to say it's strange, like Belgians are strange. Sense that.
But there's no clue as to what what would have caused that asymmetry, right?
Well, we have ideas. Certainly in what are called grand unified theories, there's lots of candidate mechanisms to make that happen. But we don't know which if any, is true, and because haven't yet been able to empirically study that. We're looking. One of the things that tell us this is physics is a two-way street. If you could create matter, then matter can eventually decay. And so one of the requirements is, in fact, that, as my friend Shelley Glashow would say, diamonds are not forever. That protons will eventually decay, and you can calculate, if the ideas are right, how long protons should last. And it's a hell of a long time. It's 10 to the 55 years. But how the heck can you measure this? Well, one simple way is to get 10 to the 35 protons together, and then on average, one will decay each year. And that's what we're trying to do in these big, large proton decay detectors. We have 50,000 tons of water sitting in a dark mine underground in the dark, and we're waiting to see if a proton decays. Now, we haven't, but if we do, it'll give us a lot of insight into the processes that created everything in the first place.
Our next question is from Comslave asks, his question is, what is your opinion of M theory?
Well, I'd say it's I mean, it's not a theory yet, in the definition of a scientific theory. It's an idea, and it's a fascinating set of ideas that may one day explain something. They haven't yet. The mathematics developed for M theory has been very useful in physics. I should say that recently, because it allows you to perform calculations in other areas you might not be able to perform. But this idea that which is, it arose out of string theory, which is fascinating and got lots of interesting reasons to think about it. It may be one way to bring gravity together with quantum mechanics, but to date it's not been very successful at explaining anything or even reproducing the universe we see. So that doesn't mean it's wrong. It just means, as I tell my friend Brian Greene, who I was just with tonight, it's not yet ready for prime time. And then he gets mad.
Speaking of something being called a theory that might not be could not substantially be called a theory, I watched a lecture given by Dan Dennett a little while back, and he within the lecture he said that string theory and the history of string theory can be summed up with one guy telling another guy, "I think the entire universe is made up of strings,"
well,
and the other guy goes,
cartoon. Yeah.
and then the other guy says, "Well, what does that mean?" And the first guy says, "I don't know."
That's right. Actually, it's from my Universe to Nothing lecture too. But and actually, I got it from XK Comics or XD Comics. It's really a great cartoon, and it really is. That sums up string theory. I don't know.
So basically,
I don't know. I'm glad some people are working on it. Maybe they'll make some progress. I'm not against it. It's just not yet worth spending a lot of time talking about in public.
Is it that it just has no explanatory power as it is, or?
Not yet. I mean, not yet. Not in terms of our universe, but there are a lot of interesting ideas and work worth being thinking about. And as I said, the mathematics is useful in trying to do something in what's called the strong interaction, but it has no explanatory power right now. We don't even know what the damn theory is. Okay, we don't even know enough about it to know what it is. So it's really preliminary, and it's important that some people work on ideas, and some those people think it has great promise, and maybe one day it will. But as my friend Frank Wilczek says, when it's like saying it, when people say it's promising, and as he says, it's promising, and it keeps promising, and it keeps promising, but that's all so far. Anyway.
So I know the thing that everybody pretty much wants us to get into is the Higgs boson particle, and the discovery. And I've been talking to a lot of people online about this, and again, as I'm not a physicist, I'm not a whole hell of a lot sure what the implications are of the discovery. And a lot of people have been messaging me saying, yeah, I don't really see what the big deal is. I don't really think that this is anything that's important. But clearly it is, or else people wouldn't be making such a huge fuss over it. So could you explain what the significance of this discovery is?
Well, first thing, I've just written 4 pieces explaining it. One piece is coming out in the New York Times on Tuesday. So I suggest all of you read the Science Times on Tuesday. I spent at great length explaining why it's important and what it is. And then I've also written pieces for CNN, Slate, and Newsweek, all of which have just come out. So they're all on the web, and so I'm a little tired of talking about it, but I'll talk about it. I've been doing a million interviews about it as well. And but it is the capstone of the most remarkable intellectual achievement that humans have ever come up with, the standard model of elementary particle physics that explains everything we see in nature and explains and unifies various forces. But it can only do that under a really weird presumption, which sounds so weird it seems too good to be true, and I didn't even think it would be until the Higgs was discovered. The idea is that there's two forces in nature which are very different. And one is electromagnetism, responsible for electricity and magnetism and light. And the other is the weak force, which is a much weirder force. It operates at very short range, and it's responsible for nuclear reactions that power the sun. They're very different. One is very weak, one is not so weak, one is long range, one isn't. We can understand, but what's been discovered is that the two of them can be unified in a single theory, with a single set of mathematics. And that's weird, because the reason they're so different is the carrier of one of those forces, the photon, electromagnetism, is massless. And that's why electromagnetism is long range. The carrier of the weak force, the carriers of the weak force, which were discovered at CERN about 25 years ago, are very massive. They're 100 times the mass of the proton, and that's why the two forces are so different. How can we unify two forces that are so different? The answer is that if it turns out that at a fundamental level, all of the particles are massless that convey the forces, then they obey the same kind of mathematics. And you say, hold on a second, but I've measured the particles that convey the weak interaction, they're very heavy. Well, if there's this background field that's invisible throughout all of space that you can't see but particles can interact with, if the particles that convey the weak force interact with that field, they get slowed down. They act like swimming through molasses, and they act heavy. But the photon doesn't happen to interact with that field, so it remains massless. And that would explain why those two forces are very different. Now, that same idea can be used to explain why a lot of elementary particles have mass. The ones that interact with that field more strongly get more massive. The ones that interact less strongly are less massive, and the ones that don't interact at all are massless. Now, that just sounds too good to be true, because it's like a scam. All the masses of particles are due to this empty space, to nothing. It's an empty space. And it seems crazy, but one of the properties of quantum field theory is if you bang a field hard enough, with enough energy, at a certain point, you'll produce real particles. So one of the predictions, as I say it in the New York Times piece, inventing invisible fields that do things is the province of religion, not science. In science, you want to be able to see it. Well, one of the predictions is if this field exists, boom, if you hit it hard enough, you should create particles. We've been trying for 40 years to build an accelerator that can hit it hard enough. And the Large Hadron Collider was the first one, and lo and behold, much to my amazement, because most theories are wrong, our theoretical ideas were right, apparently, and the Higgs field apparently exists. And then if that's the case, it's responsible for our very existence. We wouldn't be here if this background field hadn't been created throughout the universe. So it is profoundly important if you care about your own origins. And if you don't, then it doesn't matter.
Yeah, there was one thing that I've come across in some comments here and there on the internet, people who don't seem to understand that the relation this has to gravity. This isn't mass as in gravity, right? It's just mass as in resistance to acceleration, or...
Well, it's the same thing. Gravity says, the equivalence principle says that we're the same thing. And so once particles have mass, then they behave a certain way under gravity. And this does that to particles. It gives them mass, which causes the kind of gravity they produce to be different than particles without mass. Now, particles without mass still have gravity, still have gravitational attraction. Photon. It's energy that gravity is a source of gravity, not mass.
Yeah, exactly. Most people don't know that, though.
Yeah, well, now they do.
Yeah.
Anything else? I got do laundry and pack because I got to leave last.
We won't keep you too long. I think we're only going to be on for like 20 or so minutes.
20 minutes? Oh my God! Okay. I mean, not last long because I'm sorry, but we can go on a while longer. But I really, unfortunately, got back, and I do have to vacate this condo in a little bit. So.
Oh.
All right. Well, we don't want to keep you longer than you can stay. But another question that I had was after I was watching your lecture that you gave. You talked about the fact that in like 500 years, a lot of things that we know about physics will be completely wrong. Like everything will just change.
Well, I don't think I said that, but I think I said about, I was talking about 1 trillion years from now, how our picture of the universe, not 500 years, but 1 trillion, slight difference. For a philosopher, it's probably not a difference.
Zing!
Anyway, and so the universe in 1 trillion years will be very, very different than the universe today. All of the galaxies we now see will have disappeared. They'll be moving away from us faster than light, and there'll be no evidence of the Big Bang. It's kind of remarkable, and I like that fact that the future is miserable, because it indicates to us that we have this incredible conceit in evolution. We have this incredible conceit that we're somehow the pinnacle of evolution, when we're just a stage of it. In the universe, we seem to think the universe was created for us, and it's always going to be like this with these stars, and of course it's not going to be. We're here at a specific moment, and we should realize just to enjoy the moment, because the universe ain't going to be the same much longer. As my friend Christopher Hitchin would say when I talked to him about this, why is there something rather than nothing? He'd say, what you can say is, just wait, there won't be for long. So.
See, a lot of people find that thought depressing, the fact that we're not going to be here for too long, as far as the cosmological scale goes.
Well, people find dying depressing. That's why they invented God.
Yeah. We have another question from the chat. What do you think about the name God particle?
Well, you can read my piece in the Newsweek today online, which is called The Godless Particle. Yeah. You can see that the name God particle is very unfortunate, because if anything, the Higgs particle further reinforces the notion that the universe could come from nothing without God. It was a very unfortunate, stupid name created by a friend of mine who's a physicist, who, in a book he was selling many, many years ago, and for some reason the press has picked up on it. But it would be great to end that. So you can read my story about the godless particle.
Yeah, I heard that there was like I don't know who told me this. It was somebody in our chat here, but somebody told me that it was supposed to be called the goddamn particle because nobody could find it.
Well, that's what Leon says, but I'm not sure. We'll never know.
We have another question from the chat room.
Oh dear, this is going to be a nasty one.
Two colliding galaxies, one clockwise spin, one counterclockwise. How is this resolved, and is it possible that both spins are maintained and solar systems pass by each other on a galactic level?
Well, the answer is when two galaxies collide, most of the time, most of galaxies are empty space, so all the stars go right through all the other stars. And you don't get any stellar collisions, for the most part. You get a few, but not many. But the gravity of all of those things mixes up the galaxies. And in fact, if you start with two spiral galaxies and they collide, they all get all mixed up and you end up in a big ball with something called an elliptical galaxy. So what would happen is the two galaxies would end up probably forming some spherical or elliptical object. If they were bound, if they're traveling really fast, they'll go right through one another. And some stars will get torn out of each galaxy, and then the two galaxies will move on. But if they're not moving very fast, they'll go through one another and bounce back and forth, eventually merge and collide. And if you can go online and see really very pretty pictures of the numerical simulations of colliding galaxies. Next.
Well, that's what I really want to get into here is that I've been getting a lot of flack from just about everybody. I even got flack from you about philosophy. Don't you think that there's like at least some sort of importance in philosophy, even in physics? I mean, isn't that how we come up with pretty much every single interpretation? The
sense that philosophy is important to reflect on empirical knowledge, if you want to call that philosophy, reflecting on what we know about the universe and trying to interpret it and think about it, then absolutely. But from the point of view of determining what is empirical knowledge, then that's science. So philosophy follows science, but I mean, philosophy used to be science. Science was natural philosophy, and then the domain of pure philosophy has been shrinking and shrinking and shrinking. There are areas of ethics and other areas where it may be relevant, but what I guess I want to say is that, of course, philosophy, in the sense that philosophers thinking intelligently and logically about what we know about the universe and trying to interpret that and apply that to the human condition is a useful activity. But that's different than pretending that philosophy can determine, that philosophy determines ideas like something and nothing, that abstract thinking about it matters. It doesn't.
I don't think. I think aside from people like maybe William Lane Craig and John Lennox, I don't think the vast majority of philosophers would like to replace science with philosophy when it comes to empirical theories.
That we because we don't define things in the way they'd like, they get upset about it. And someone reviewed my book recently, got very upset because I didn't define nothing the way they define it. Well, all I want to say is, look, it's not. I mean, I was being provocative. I wrote a piece called "The Constellation of Philosophy," talking about exactly where I think philosophy fits in. And the point is, for better or worse, it may be a useful intellectual activity, but it doesn't impact on science. It has zero impact on science for the most part, the philosophy of science in particular. And even the scientists like me who've read philosophy of science have tended to learn about the philosophy of science not from philosophers, but from the example of scientists like James Jeans or Richard Feynman or Jacob Bronowski. I learned what I know about the scientific method and even, I read Kuhn and I've read Popper, but what I learned about science, I tend to learn by doing science or watching people do science. Stuff that's written about science, the philosophy of science is generally only of interest, I would say, for the most part. And there's always a set of epsilon measure zero here, but primarily of interest to other philosophers of science. And maybe, to some extent, to the public who may not know about how science works if the book is written well enough, and most of them aren't. But it doesn't have any impact on scientists. That's all I can say.
Well, but isn't that like a historical thing? I mean, Einstein for the longest time didn't accept quantum mechanics for the same reason that philosophers are kind of pissed off at you for not defining nothing the way that they do, because it's not matching the preconceptions that have been established.
Just like it was Einstein's problem. I don't give a damn. But I thought you meant you were going to say it's historical in the sense that philosophy used to be science. I mean, this disconnect between physics and philosophy, if you want, or the marginalization of philosophy, is more recent. And certainly, natural philosophy played a key, and philosophy in general played a key role in the development of science, and I don't deny that in any way. I'm just talking about the 21st century, not the 16th.
No, I wouldn't say that philosophy is supposed to be like neck and neck with science when it comes to determining empirical theory. Science wins on that. I'm just saying that there shouldn't be a duality between the two. There shouldn't be either science or philosophy. It should be both, in my opinion.
It's not a win-lose proposition. They're not even playing the same game. I mean, that's really important. Science is based on empirical reality, and philosophy is interpreting science, if you want. And if you say that that's fine. It should interpret lots of things, but it should take its guidance from science rather than the other way around. There's nothing wrong with that.
No, I don't think anybody would disagree with that. I mean, in philosophy, well, I mean, nobody who isn't an asshat like Lennox or Craig or any of those guys.
Or philosophers of science I know who will remain unnamed. Craig is not a philosopher; he's a jackass. Or he's not. He's a huckster. I've debated him, but there are real philosophers of science who jump on this thing and say, no, you can't really discuss this unless you talk in philosophical terms, and I guess I just think that that's fine for them, but it's not necessary for scientists.
But wouldn't that help get it out to the public a little bit easier if you were able to deconstruct what you're talking about in more philosophical terms?
No, absolutely not. I think the way to get it out to the public is to explain clearly what the science is all about, like I do, and to couch it in ontological terms or deontological terms or any of the fancy philosophical notions is not to make it more accessible, but to obfuscate things. Just explain how the universe works. That's all we need to do. That's what I try and do. That's what I do for a living.
Exactly, you're taking the Richard Feynman approach of just do the math. I understand that, but
I'm trying to explain it to the public in words.
well, I understand, but when you say a universe from nothing and you don't mean nothing the way that most people mean nothing, I mean, doesn't that would create confusion in the public, would it not?
Yeah. Well, that's why I try to explain very carefully what I mean by nothing. I don't say, look, I'd like nothing to be this. I say, here's what I mean here, and here's what you can get, and here's what you can get, and here's what you can get. And if you don't think that's nothing, that's fine. But here is how to understand how everything you see could come from stuff you couldn't see, and could come from stuff that didn't even exist in a space that wasn't there. And if you don't like that, nothing. I don't care. Call it crap. I don't care what you want to call it. But it tells us it's I think the big mystery, the big miracle and the reason religion relies on it so much about creating something from nothing is it appears to be impossible to create galaxies when there were none, and it appears to violate the conservation of energy if you know anything about that, and so that's why they have to invent a deity to do it. And all I'm saying is, look, you don't need to do that. Now, you might not. It may be that having no galaxies is not nothing for you, but that particular miracle is not a miracle. And similarly, coming up with space when there's no space is not a miracle. And that's all. That's it. And whether you want to call it, getting hung up on terminology is just a waste of time.
I agree that it's a waste of time to just completely obfuscate the point and always never really address what's actually being said, but simply say, well, you're saying it in the wrong way. But the general public are not physicists, and they're not going to understand a lot of these things unless you put it in terms that they understand. Sort of,
well,
it's a coherentist approach.
Great. Have you read my book?
I have not read your book yet.
Well, then don't tell. Then when you read the book, you can ask me. You can ask me that question. But my point is, I do put things in clear terms, and in terms people can understand, and present the issue. And as I point out, colloquially, I may use the term "wise" or something rather than nothing. But what I really mean is, how is there something rather than nothing? And I make it quite clear what nothing is. And I can't do any more than that.
While I haven't read your book, I have read people who have read your book, and then they came up with the exact same criticism.
How the hell do you know they've read my book? I mean, there was a review in an eminent newspaper by some philosopher who clearly hadn't read anything but the preface and the afterword. Didn't read anything in the middle, and if he did, he didn't comment any of it. And so when people, and then I'll read, oh, he shouldn't make such tirades and spend so much of the book talking about God. I think there's 1 or 2 pages in the book where I talk about religion, maybe 3. And it always amazes me. I've discussed this with my friend, with Richard Dawkins. All you have to do is bring up the subject of whether God is unnecessary. And suddenly you're having a tirade and you're spending way too much time and you're strident and you're all the rest of this. Look, my book is a book about cosmology and a book about how the universe works. And yes, I point out that it means that there's no need, that it means that there's a possibility that it's plausible that there's no divine creation, there's no divinity there, and omnipotent whatever, and the fact that it's plausible is worth celebrating.
I agree, and I'm not trying to be combative here, so I just want to make that clear. I know you're probably kind of annoyed with the fact that the media and myself, I apologize, keep asking you pretty much the same questions over and over. What would you rather they ask you about?
How I got to be so good looking. No, I have no problem. But when I answer it, what frustrates me is when I answer the question, to be asked it a second time and then a third time frustrates me. But I think discussing what nothing is vitally important. In fact, if I can provoke people to think about nothing, and I would argue most people who use the words, out of nothing comes, or only God can create something of nothing, have never seriously thought about what nothing is. And if my book and my writings and my work can provoke people to think about that, that's fine.
A lot of us. Go ahead.
We have another question here.
Higgs wasn't a lot. I don't make predictions, but I doubt he'll win well, if he wins the Nobel Prize this year, it would be very unusual because the Nobel Prize is given for work the year before, or at least before that. And the nominations, since I happen to not have in the past been a nominator for the Nobel Prizes, they are due January 31st. And therefore, while there was tentative evidence for Higgs last fall, it would be interesting to see if the Nobel Committee decided that that was good enough with the information that follows to give him and some others the Nobel Prize. I suspect that if the Nobel Prize is going to come, it would come the year after this, but you never know. They may decide.
We were actually discussing this on an hour earlier. How do you think they'd even handle giving out the Nobel Prize? Because there was 2 teams involved, and many people, and there's only about like 3 people who are allowed to get it.
There are only
at a
3
time.
people at it, and there are ways to determine who had the biggest impact. And the Nobel Committee is very, very good. They spend a full year. The day after the Nobel Prizes are given out, they start the next year. They spend an incredible amount of time trying to make mistakes. And on the whole, they've been damn good at it. But I don't care. I mean, it's just going to be, it doesn't matter. They'll decide some combination or not. But, it's not for, the prizes are arbitrary to some extent. But there are colleagues of mine who were more familiar with what was going on at the time that Higgs was there, and others who would be able to, I think, pick 3 key people from the set of people who were doing it, the 3 who made the biggest contribution, and I assume the Nobel Committee can do that. They have to do that a lot. I mean, they did. This year's Nobel Prize went to 3 people, but they were involved with a collaboration of 50 people. 2 different collaborations, and they try very hard to not make mistakes. So, and if they gave it for the experiment, that discovered the Higgs, maybe they give another one for the experiments. Well, each experiment has 3,300 people on it, and you've got to, so at some level, they're arbitrarily picking, but they try and be pretty careful about it. And it's just a damn prize, so what the hell? Doesn't matter.
What do you think is going to be the next step after discovering the Higgs boson? What's the next step after that?
We've got to be sure it's a Higgs boson that's been discovered. We don't know that for sure. Okay, it looks like a Higgs boson, but we don't know it for sure. So the most important thing to do is to see if it's a Higgs boson, to do tests, because it's very preliminary. There's only 30, 40 events out of 10 billion that they can measure, and it's really preliminary. It looks and it's walking like a Higgs and quacking like a Higgs, but we don't know if it's a duck yet. But after that, the question will be: if it doesn't look exactly like the Higgs of the Standard Model, then that'll be really interesting because it'll mean that it'll point towards new physics. Because the Higgs doesn't solve all the problems. The question is, why does the Higgs field exist in the universe? We don't know. Why does it have the mass it does? We don't know. And we think the key to answering those questions involves lots of new physics that should be accessible at the Large Hadron Collider. So it's the beginning of what could be a very, very exciting journey in the next 10 years.
Is there any work that you're working on right now that we could look forward to in the future?
Everything I do, you can look forward to in the future. You mean scientific or writing? What do you mean?
I think why not both?
Well, I'm working on lots of things from dark matter to dark energy and gravitational waves in the early universe, the formation of structure, and some interesting ideas that I'm just thinking about dark energy. I don't know what's going to be important, what will work out. I think we've just done some very interesting work that corrects some mistakes about the formation of structure in the universe, and probing for new processes in the early universe. And I'll be writing. If I wasn't talking to you, I'd be working on a proposal for a new book, which I hope will come out in a year or two, which I'm not going to tell you about. And then I'm doing lots of other things. I'm actually a new movie that I've been filming with Richard Dawkins that's being made about us, which should come out next year, a full-length feature film. So watch for that.
I just got another question. What do you think are the greatest breakthroughs in science, in physics specifically, in the past 100 years?
100 years? The development of quantum mechanics, general relativity, quantum mechanics, the understanding of quantum field theory and particle physics by Feynman and others, the discovery of dark energy, Certainly, the fact that the universe is accelerating. We don't understand what the energy of empty space is. It's the biggest mystery. And then the development of the Standard Model. 50 years ago, we knew of understood only one force in nature as a quantum theory. Now I understand three. It's an amazing intellectual voyage, and it's certainly worth celebrating. And we can all celebrate it.
I haven't mentioned this at all during the hour, and that's a shame on me. Everybody, by the way, who is watching right now, remember the donation thing is still there. Helping the homeless is always a good cause to donate towards. We still need more money. We're at $1,800 now. We could probably do more in the next couple hours. We are. I know you really are very anxious to unpack and get going.
Hours, almost so. Almost. So.
Yeah, I know you're extremely anxious to get going, so I'll start wrapping it up now if you like. So, big thank you to Lawrence Krauss for coming by. We are very appreciative of that. I apologize if I seemed a little combative when I was trying to defend philosophy. There are people yelling at me in the chat room, "Why are you being mean to him?" I'm sorry.
I can handle it. Don't worry about it.
I know you can handle it. You went with you talked to William Lane Craig. I mean, after that, I can't possibly say anything to you. So yeah, thank you very much for coming, Dr. Krauss. And Mortimer, do you have anything you want to add?
No, just thank you.
It's been a pleasure. I'm glad I managed to get online, and I'm sorry for being a few minutes late. But
no problem. No problem.
Good luck to all of you in your efforts to raise money, and good luck in your work. You take care. Bye-bye. Bye.
Bye.